My dear student, physics class for class 9, chapter number 5, state of matter, and pressure. My today's topic is Archimedes Law. Okay. So, as a student, Archimedes Law. Archimedes said that if you want to keep a body inside liquid, then this body will lose some part of its weight. Suppose, my dear student, if you take bath inside water or inside pond, you see that you feel some less weight inside water or inside the well. And from this, Archimedes said that this amount of lost weight will equal to what? It will equal to here weight of the displaced liquid. What does it mean? It indicates that when you keep a body inside the liquid, then some part of the weight of the body is lost. And this weight lost by the body will equal to weight of the displaced liquid. Suppose the more amount of water is displaced by the body, its weight lost is more, and the less amount of water is lost by the body, its weight lost is less. So according to Archimedes' law, the basic statement is here: when a body is fully or partially immersed into liquid, then this body lost some part of its weight. Which is equal to weight of the displaced liquid. So, my dear student, when a body is fully or partially immersed inside the liquid, and there is a condition here in static position. So liquid is at a static position. Then you see that that body will lost some part of the weight. My dear student, you see that that body will lost some part of the weight. And this weight lost will equal to weight of the displaced liquid by the student. This weight lost will equal to what? This weight lost will equal to weight of the displaced liquid. Now, my dear student, at first I'm going to find out how I'm just going to find out the weight lost by the body. Suppose, my dear student, I'm just taking a piece of solid body, okay? So at first I'm just going to take its weight in air, and then I'm just going to find out its weight inside the water. And if I'm going to subtract weight in air minus weight in water, then you can say that that amount indicates that weight lost by the body. So mechanically, weight lost by the body will equal to what? Will equal to weight of the body in air minus weight of the body in water. So, my dear student, firstly, weight lost by the body. So weight lost by the body. Suppose I'm just going to measure this mechanically, my dear student. So I can say that weight lost by the body will equal to weight of the body in air minus weight of the body in liquid. So here weight lost is symbolized by W lost. My dear student, weight lost is symbolized by W lost. So W lost will equal to what? W lost will equal to here at first weight of the body in air. So weight of the body in air minus then weight of the body in liquid. Suppose this is equation number 1. And Archimedes said that there is another equation to find out the weight lost. And that weight lost will equal to what? That weight lost will equal to weight of the displaced liquid, my dear student. That weight lost will equal to what? That will equal to weight of the displaced liquid. So, according to Archimedes, weight lost will equal to what? Weight lost by the body will equal to weight of the displaced liquid, my dear students. Now, weight lost is symbolized by W lost. What is the value of the weight of the displaced liquid, my dear students? You know that the value of the weight of the displaced liquid is nothing but its buoyancy, according to my last class. You see that because of buoyancy, some part of weight is lost. Okay, and because of this buoyancy, okay, if you're going to take a bath inside water, you see that you just feel a little bit less weight. You just feel lightweight. Okay, and this lightweight depends on the value of the displaced water or displaced liquid, and this weight of the displaced liquid is nothing but upward thrust, or in short is known as buoyancy. Okay, so how can I calculate buoyancy, my dear student? You know this very well. The buoyancy will equal to what? It will equal to V rho G. Now, my dear student, this rho equal to what? This rho equal to density of liquid. Density of liquid, my dear student, and this V equal to what? This V equal to total volume. Total volume, or basically this is nothing but volume of the displaced liquid, my dear student. Basically this is nothing but volume of displaced liquid. Okay, my dear student. So this is the total volume, or this is nothing but here volume of displaced liquid, my dear student. So Archimedes said that when a body is kept inside liquid in a static position, then what is happening here? This body will lose some part of its weight, and this weight lost will equal to weight of the displaced liquid. Now I'm going to write down the mathematical equation of Archimedes law. You see that this is the mechanical weight lost. Okay, and you also see that from the Archimedes law, we're just going to find out the value of weight loss. This is V rho G. So the equation of Archimedes law is the equation of Archimedes law is weight lost, means what? Weight in air minus weight in liquid. You may take kerosene, You may take most of the time water, okay? Or you may take any other liquid medium. So weight in air minus weight in liquid or kerosene. And this part will equal to what? Will equal to V rho G by the student. Or this part will equal to what? Or this part will equal to F up, upward thrust. Okay. So this is nothing but equation for the case of Archimedes law. So from Archimedes law, this is the equation by the student. After this discussion, any one of you, any confusion? By the student, after this discussion, any one of you, any confusion here? By the student?
No, sir.
Any confusion here, any one of you?
No, sir.
Okay. So if you have no confusion, then I'm going to solve some creative question on the basis of this theoretical concept. By the student, I'm going to solve some theoretical question, some creative question on the basis of this concept of Archimedes law. So let's solve some creative question. Before starting this, your writing is completed, my student. Can I erase this board?
Yes, sir.
Sir.
Oh, very good. So my student, I'm going to solve some board question, some creative question on the basis of this Archimedes law, on the basis of this concept, my student. Okay, now my student, this is a board question. It's a very important board question, I think. Rajshahi board 17. The weight of a body of volume volume 400 centimeter cube is in air is 19.6 Newton. If it is immersed in water, if it is immersed in water, then its weight is 15.68 Newton. Question number C, my student. Find out density of the body of the stem. Find out density of the body of the stem. Number D question. Does the above principle support Archimedes principle? does the support Archimedes principle? Explain mathematically. So, explain mathematically. Explain mathematically. Okay, my dear student, this is a very important creative question, I think. My dear student, this is a very important creative question. Okay.
স্যার এটাই তো আমাদের অ্যাসাইনমেন্টে দিয়েছে
This is a board question, my dear student. This is a board question. There is a question for Rashtriya Board 17. Okay, my dear student.
অ্যাসাইনমেন্টে স্যার এটাই স্টেপ
There is a board question, Rashtriya Board 17. Okay, just I'm going to solve this question. Now, my dear student, you see that the weight of the body of volume 400 centimeter cube in air is 19.6 Newton. If it is immersed in water, then its weight is 15.68 Newton. In question number C, I'm going to find out the density of the body of the stem. Now let's find out this density. My dear student, give me some idea. How can I find out density of the body? My dear student, give me some idea. How can I find out density of the body? Any idea, my dear student? Any one of you?
By dividing the mass by volume.
Very good. You know that density of the body rho will equal to what? Will equal to mass per unit volume. This is equation number 1. And next problem is here. There are two weight is given. One is weight in the air is given and weight in water is given. Okay. So from which weight we are going to find out the mass of the body, my dear student? From which
Air.
weight? Yes. Yes, my dear student. From which
Air.
we are going to find out mass of the body from weight in air. You know that weight in air will equal to what? Will equal to m into g. Now, here m will equal to what? M will equal to weight in air divided by g. Okay? So, weight in air will equal to 19.6 Newton and g equal to 9.8. Now, my dear student, it will equal to 2 kg. So, density of the body is from equation 1, rho equal to mass per unit volume. So, mass equal to 2 kg. Now, what is the volume? My dear student, you see that volume is given 400 centimeter cube. You need to convert this 400 centimeter cube in terms of meter cube. Okay, so how can I convert this? 400 divided by 100 cube. My dear student, 400 divided by 100 cube. So find out the value of the density of the body in terms of kg per meter cube. In terms of what? In terms of kg per meter cube. My dear student, in terms of this kg per meter cube. Now find out this. What is the value of the density of this body?
$5,000.
It will equal to 5,000 kg per meter cube. Okay. Any one of you, my dear student, any confusion here? My dear student, any one of you, any confusion here? My dear student, any confusion in the solution of question number C? My dear student,
No, sir.
any confusion here? Okay,
No, sir.
very good. Now, my dear student, question number D. It's said to me that does the above stem support Archimedes principle? Explain mathematically. So let's see if it support Archimedes principle or not. Okay, in question number D. So, question number D. You know that according to Archimedes law, you can say that according to Archimedes law, you can say that weight in air minus weight in the case of this is weight in water, because this body is immersed inside water. Weight in water will equal to buoyancy or upward thrust, my dear student. Suppose this is equation number 1. I'm going to show this given stem can support or not the Archimedes law. So at first I'm going to put down the values in the left side of this equation. So left side of this equation 1. It will equal to, my dear student, weight in air minus weight in water. Now, my dear student, here weight in air equal to 19.6 Newton minus weight in water equal to 15.68 Newton. So, what's the change of weight? Change of weight equal to here
3.9.
9 Newton. And confusion, my dear student, from this part? My dear student, from this part and confusion here? Okay. So it will equal to here 3.9 Newton. Now, my dear student, from right side. It is F upward or upward thrust or buoyancy. You know that equation for buoyancy equal to V rho G. Now, the volume of the body is given. This is 400 centimeter cube. So this is 400 divided by 100 cube. What is the value of density rho, my dear student? What is the value of density rho? It is 1000 kg per meter cube for water and G equal to 9.8. Now find out this buoyancy part from this Archimedes law or from this given information.
Same value, 3.9.
So it will equal to same value like as before. This is 3.9 Newton. Now, can you say this given data information can support Archimedes law, my dear student?
Sir.
This given data can support Archimedes law. Can you say this, my dear student?
Yes, sir.
Okay, so you can
Yes,
say
sir.
that. So you can say that from this calculation, you can say that given data, given information can support Archimedes law. My dear student, given data, given information can support Archimedes law. Have you any confusion about this creative question, Russia about 17? My dear student, have you any confusion about this creative question, Russia about 17? And confusion here, my dear student? Any one of you, any confusion here?
No, sir.
Okay, very good. Now I'm going to solve another mathematical problem, another creative question. Okay, so I'm just going to solve another creative question. So my dear student, another creative question. Dhaka board 17. The weight of an object of area, the weight of an object of area 20 centimeters square and height 10 centimeter. Height 10 centimeter. In air is 9.8 Newton. In air and water R and 7.8 Newton. Respectively. Very complex sentence. Question number C. Find out or calculate the density of the body. Calculate the density of the body. And now, my student, question number D. Does the stem follow Archimedes law? Does the stem follow Archimedes law? Archimedes law. Explain mathematically. My student, explain mathematically. Explain mathematically. Okay. So this is another board question, just like previous one. This is another board question, my student. Dhaka board 17. The weight of an object of area means area here, 20 centimeters square, and height 10 centimeter, in air and water are 9.8 Newton and 7.8 Newton respectively. This is a complex sentence. In question number C, it is said that calculate the density of the body. By the student, just we're going to find out the density of the body, just like my previous math, just like previous question, Rashi book 17. So let's see how can you solve this question. How can you solve this mathematical problem, my dear student? You see here, density rho is nothing but mass per unit volume. So in this question, at first I'm going to find out the mass of the body, and then I'm going to find out the volume of the body, my dear student. So firstly, I'm going to find out the mass of the body. There are two weight is given. One is weight in the air, that is 9.8 Newton, and another is weight in the water, that is 7.8 Newton. So always remember that mass of the body is find out from the weight of the body in air. We can say that weight of the body in air, it will equal to m into g, my dear student. Now from here, I'm going to find out the value of mass. It will equal to weight in air divided by g. So this is 9.8 Newton divided by 9.8 meter per second square. Will equal to 1 kg. Now, my dear student, next step, I'm going to find out the volume of this body. You know that area is given and also height is given. So by using the area and by using the height, we can find out the value of our volume very easily. Volume equal to what? Volume is nothing but here area into height. I repeat, my dear student, volume is nothing but here area into height. So volume V equal to what? V equal to here area into height. So area equal to 20 by 100 centimeters square, and height equal to 10 by 10 100 meter cube. Now find out, my dear student, what's the volume of this body in terms of meter cube. I'm just convert this centimeter in terms of meter.
-04.
Yes, my dear student, this is
Sir, volume is sir 10 into 10 inverse -04.
200 divided by something will equal to, we said that this is 2 into 10 to the power
-4.
-4. So this is 2 into 10 to the power -4. Very good. -4. Okay. Now, from equation 1, the density of the body rho will equal to what? Mass per unit volume. So mass is 1 kg and volume is 2 into 10 to the power -4. So something kg per meter cube in unit. Now find out its density by the students. Now find out its density.
Five thousand kg per meter cube.
So it's also 5,000 kg per meter cube as well. Okay. So it's also 5,000 kg per meter cube. Is it correct by the student?
Yes, sir.
Any confusion by the student? Any one of you? Any confusion here? Any confusion here by the student? Any one of you? Any confusion here?
No, sir.
Okay. Now, I'm going to solve question number D by the student. So, let's solve question number D. Does the system support Archimedes law or not? You know that according to Archimedes law, now question number D, according to Archimedes law, we can say that according to Archimedes law, weight in air minus weight in water will equal to what? Will equal to upward thrust or buoyancy. Suppose this is by the student equation number 1. How many times are left? 3 minutes times are left. Okay. So put down the values in equation 1. This is weight of the body in air minus weight of the body in water. So what is the weight of the body in air? This is 9.8 minus this is 7.8 by the student. So it will equal to 2 Newton. In right side by the student. In right side, this is upward thrust or buoyancy. This is upward thrust or buoyancy by the student. So upward thrust or buoyancy is nothing but this is V rho into G. Now V equal to what? V equal to here 2 into 10 to the power -4. Density rho equal to 1000 and G equal to 9.8. Now let's justify this. It can support Archimedes law or not.
The value is 1.96.
The value is here 1.96 Newton. So if you say that approximately it can support Archimedes law, it is correct. If somebody said that, sir, it doesn't support Archimedes law, this is also correct. So in this situation, you can make 2 conclusions. You may say approximately it can support Archimedes law. And if somebody said that no, it doesn't support Archimedes law, this is also correct. Because these 2 part of value doesn't match exactly. Okay, by the student? Any confusion? Anyone of you are my student? Any confusion here? My student?
No, sir.
Anyone of you? Any confusion here? Okay. So my student, is all about my today's class. If you have no confusion, then see you my next class. Okay? So ভালো থাকবা, দেখা হবে ইনশাআল্লাহ সবার সাথে।